Welcome back. Thanks for joining me for Skills Measured Area 3, Deploying and Managing Azure Compute Resources. In this lesson, we'll discuss the following areas. 3.3 Subgroup, Automate Deployment of Resources by Using Templates. 3.2 Create and Configure VMs. 3.3 Create and Configure Containers. And 3.4 Create and Configure an Azure App Service. Let's start with discussing deploying resources to Azure. The Azure Resource Manager is a management layer that allows your Azure Resource Service, Manager service, to authenticate and authorize requests. Azure Resource Manager then routes those requests to the appropriate resource provider. So you should know from your self-study what resource providers are and how they relate to your subscriptions and managing the services that can talk to ARM. ARM also allows a unified layer to utilize the following tools: the Azure Portal, Azure PowerShell, Azure CLI, as well as REST clients, which are all possible with the use of Azure Resource Manager. It may be a great idea to understand all the implications of Resource Manager and that we don't use the classic model for deployments any longer. It's considered legacy, but it still may appear in the portal. You may not see any questions about the classic model on your exam. Whether your deployment is a single resource or to a group, or you use a template to create a group or manage dependencies, the Azure Resource Manager is a key consideration which acts on your behalf. There's nothing that you need to install. It updates automatically. It is highly available across regions and globally. And currently, you're able to use this resource manager to allow you to interact with resources and tags and governance. So a key component of the exam is understanding that Azure Resource Manager is that tool or that layer of management that allows you to track your execution and create dependencies between all of the layers of resources that you see here. There's also a consideration for how it authenticates uh, to interact with all of the services that your subscription is connected to and how those resource providers are enabled. So it would be a great idea to understand how to enable and disable providers as it relates to ARM. Azure Resource Manager enables us to work with resources as a group. So this consistent management layer allows us to audit, to update, to deploy or delete in a singular coordinated operation. It provides security, auditing, and tagging features as well. So we have the Azure Resource Manager to thank for that. And from our journey, our learning journey, we know that there are a lot of tools to include the ones that we mentioned in the last slide that allow us to create declarative syntax as well to manage these resources. Some of the benefit for using ARM would be to give us the ability to create repeatable deployments in our solution throughout a development lifecycle using ARM templates. ARM, Azure Resource Manager, in conjunction with JSON, JavaScript object notation, allows us to create ARM templates. A template is a structured approach to deploying our resources using a format where we can define infrastructure as code to test, to share, to redeploy resources very quickly. So for the exam, if we're looking at this ARM template, we may want to know the components. We should know the components required to create a resource manager template with definitions for what resources can be deployed either into resource groups or as a single operation. Some of the key benefits to include faster deployment, more repeatable structure for infrastructure as code, and the syntax, the declarative syntax or JavaScript object notation, that JSON syntax that we saw in the last slide. Um, Also, with that, all of the components for creating an ARM template to include the schema, content version, parameters, variables, functions, resources, and outputs. Some of these uh, components are optional and some are required. So a question may ask you, of these offerings or these various components, which are required and which are not? We know the correct answer to be schema, content version, and variables. We can't have a template without these three things. So memorizing or remembering that these components are required while the other are optional would be a great way to manage your knowledge of ARM templates before the exam. Also think about orchestration here. How would you orchestrate a template? Where would you go in the portal to uh, review an existing template or create a new one? Either through a resource that you already have deployed or to the deployment center to create a resource from a quick start template would be another example to create the same process multiple ways. And then we have the Azure Compute Gallery. The Azure Compute Gallery helps you build structure and organization around your Azure resources, like images and applications. It provides global replication, grouping, and versioning of your resources for easy management, premium storage support, replication strategies that are highly redundant, like zone replication, scaling for your deployments with resource replicas, and some sharing of your identities that are mapped to your Azure Active Directory tenant and management using RBAC, even across subscriptions. To create a singular compute resource, we know from our learning journey that an Azure virtual machine and any of the associated resources can be created through the portal, through the browser interface, or with any other systematic creation deployment approach, like IaaS. So know the various ways to deploy a virtual machine. Also understand the components that are required or optional for virtual machine creation or configuration. We have the ability to start out with some basic requirements like project details to include the subscription and any associated resource group you might map a virtual machine to. You absolutely need to choose an operating system for a virtual machine, either from the marketplace or through some other image deployment type. Know those. You have optional access to create data disks during deployment or after. So during the time of creation or as an incremental addition, add later. There are various types of data disks, right? HDD, SDD disks, some ultra performance disks, and those will have everything to do with the SKU or stock keeping unit that gives you an abundance of features that align to those offerings. So you do have some options there. And so further that thought, you may be asked where, again, the data disk might be stored. From the previous functional group, if you joined me for that, you'd know that that would be Azure Storage inside of Storage Account as a page blob. Networking components define what portion of your virtual infrastructure this virtual machine will live in, and how it would communicate with other things will be something that you optionally map. As well as backup monitoring, auto shutdown, which could give you some cost savings, and configuration of agents and scripts, which are optional deployments as extensions. We remember this from our study. Extensions that we can use during deployment or post deployment. Managing our virtual machine sizes is very easy and simple. From our study, we know that we can choose a virtual machine option or size as a choice from a wide variety of offerings to mix the type of compute, memory, storage, to create some sort of a version of a virtual machine that you'd like to see implemented. So you can choose from a variety of these VM sizes, which give you the type of workload that you'd like to run and customize to your environment based on the size. So very important here that you kind of associate or know the association of the size to some of the use cases and types that you could see on the exam, like the D series being most popular for general compute resources, or N series for GPU enabled or based workloads, maybe for data science needs. That would be an example that you could see on the exam. Which of these would be used for high-end computational theory virtual machines? Which one would support that? The correct answer in that case would be N, if your options were N, D, or B, for example. Now, let's recap what we need to know of application workload connectivity options. Before we deploy a virtual machine, we might want to think about where we need to use this virtual machine, where it needs to run. Um, when we create and run a virtual machine that needs to live in a specific domain, have network connectivity, we should think through the placement of how this workload will interact with our virtual network infrastructure. Network connectivity can be provided in one of two ways. You can create a virtual network subnet, so a smaller isolated version of a larger VNet. Remember, a subnet is going to be a segment of the larger virtual network. And as VMs are a part of the same virtual network, they can automatically perform name resolution and communicate with Azure AD, Azure Active Directory, domain services, domain controllers for name resolution. We can also configure Azure Virtual Network Peering for managed domains virtual network. So mapping connections from one virtual network to a separate virtual network using what's called a peering. When you configure a virtual network peering, you must also think about things like name resolution with DNS and any settings that could potentially block communication from one area to another. You want to resolve those, right? Usually, you only use one of these network connectivity options, and that choice will be dependent on how you wish to manage and separate your Azure resources. Speaking of resources, we talked about resource groups in a previous module. Resource groups, again, allow us to choose to create a grouping, a logical grouping or container of items that have similar life cycle. We will place a virtual machine inside one and only one resource group. So true or false, can a virtual machine live in multiple resource groups? Absolutely not. But we can use a resource group to manage the life cycle for all the items within it, incrementally adding or removing resources as needed. We can also use resource groups as a way to transfer resources from one life cycle group to another. So know the differences between the options that you or operations that you can and can't perform with a resource group. And in this case, for virtual machines specifically, may not be true for other objects, we can create a virtual machine and move it to a new resource group with move functionality. We can also move across subscriptions as well. So understand the implications for moves within resource groups for the object that we're talking about specifically, in this case, compute resource. Might be different for other virtual networking objects or other objects in Azure that do require recreation versus move operations. Another component that we'd like to discuss or think about when we're creating a virtual machine is the addition of data disks, which we mentioned could be added during the creation of a virtual machine deployment or after. So we have the option to use the portal to determine our virtual machine size and the number of maximum data disks that can be attached in that operation would be determined by the size of the virtual machine that we deploy if we're going to use that virtual sizing option. So in this case, we see an example of creating a new virtual machine disk where we would store our data. Know the pricing options, not necessarily the dollars and cents, but the feature set that's associated with choosing one virtual machine data disk type over another. Understand that you can choose to encrypt your data at rest. It is the default encryption option at rest using a platform managed key as default option, or bringing your own managed keys to create secret management for your data disks. So a couple of key benefits to sitting for this exam is understanding some of the feature sets, the comparison and contrast, and being super prepared to see those examples. You can create resources to support communication of your virtual machines as well, and configuring VM network settings would be the best way to configure those items or to customize those items to include the following. Your network interface card or NIC, you should have at least one. There will be one deployed to each virtual machine type during deployment. And this is how your virtual machines are going to talk to your network. This supports that interconnection between your virtual network and your VM. You can also customize your IP selection, so know the difference between private and public IPs and what they can talk to. Private IPs are going to stay internal to the Microsoft backbone. What does that mean to you? It's the all of the network connectivity where your virtual machines or your other resources um, will use to support internal communication to an environment on the Microsoft network specifically, or public IPs. Do you want communication to the internet? And which of these SKUs or stock keeping units that you can select for IPs would support each of these types of communication? Know that for the exam. Um, Additionally, supporting communication for our virtual machines, we would need to determine our virtual network segments, our subnets. Optionally, we can communicate or restrict rules or add additional rules to restrict or allow, deny or allow inbound or external communication using NSGs. These are all optional. Know which of the IP addresses, which of these SKUs have options for closed communication automatically, which type of SKU would offer that, if that's something that you'd like to deploy. And then optionally, we can add load balancers to help us manage that traffic and balance communication between our load. Now, let's talk about high availability for a minute. Azure ensures that your virtual machines within an availability set run across multiple physical servers, compute racks, storage units, and network switches. So, optionally, during deployment or later, we can choose to create high availability using virtual machine availability sets in a logical feature or as a logical feature, which ensures that our group of related virtual machines are deployed so that if there is a point of failure, we're not affected. These are all these assortment of virtual machines are not upgraded at the same time, so we don't lose host connectivity within our data center. We are minimizing that risk. So understand the maximum and minimum requirements for selection of fault versus update domains when you're creating a highly available set of resources. Your goal here is configuring availability sets for redundancy, or maybe you structure those sets in application tiers for web versus database. Maybe you combine with a load balancer as an option. And maybe you might be a great idea to think about the differences between managed and unmanaged disks, something you definitely want to know for the AZ-104. What are the implications with managing the underlying storage? How does creating, for example, an availability set affect your service level agreement? This might be required by an organization. You need at least two or more instances of compute resources in an availability set to achieve a certain SLA. And of course, remember your stock keeping units, which equal the feature set associated with your deployments. Now let's move on to scale set, which also give us the ability to deploy multiple virtual machines uh, per configuration. A virtual machine skill set is a set of compute resources that we use to deploy and manage a set of identical virtual machines. So great idea to remember that we do have some limits, some default minimum and maximums here. Understand what that looks like. Understand that we can actually choose the type of hardware that we have supporting our virtual machine skill sets. So the size, again, similar to what we saw with virtual machines. In a skill set, we by default are going to use managed disks, and we do have the ability to scale up to 1,000 virtual machines, but there are some implications for creating scaling or skill sets above 100. So know what your limits are. You don't have to memorize limits, of course, but it is a good idea to understand that your scaling option does give you a set of instance count by default and a certain number of a certain way to exceed your limits in some cases where you can scale above that threshold. So don't go memorizing every limit for every subscription, but just know that you do have some soft and hard limits, and you do have ways to choose feature sets that allow you to vertically scale, horizontally scale, or automatically scale. This is the richness of having a skill set. You can map multiple rules, know the differences between these three types of scaling options, which is instance, which is power related, and how are you going to create certain auto scaling policies to manage either a period based time period uh, extension of a skill set or a metric condition or multiples. And for every scale out rule, there shall also be a scale in rule. Containers. Off to chatting about containers. Containers are going to offer us a way to bundle our source code and any of the dependencies and run them together on a node of some sort of compute resource. So please understand the differences between a virtual machine and a container, which would offer the fastest startup time. We describe containers as being pretty lightweight isolations from the host and other containers without, but maybe not having that as strong of a security boundary. It does have a security boundary as a virtual machine. Containers allow us to run in the user portion of an operating system, and we can tailor that portion to contain just the services we need. You're able to use other resources like Docker to package the code and all of the dependencies for mapping your microservices to your nodes. You're also able to add persistent storage. Which of those types can you add? Might be a great idea to remember. Azure Disks or Azure Files if you want to mount a mapped file share essentially from a storage account. We also get fault tolerance. So please understand some of the features, the benefits, the differentiations between containers, and virtual machines. There are a couple different options for Azure to work on containers. One of them is called Azure Container Instances. Azure Container Instances, we know from our study, offers the fastest, simplest way to deploy a container in Azure without having to manage the underlying virtual machine, without having to adopt any higher level services. So before sitting for the exam, you definitely want to understand the components of ACI to include container groups, which are a collection of containers that get scheduled in the same host. To understand that ACI does not necessarily support orchestration like Kubernetes does. So there are some comparison and contrast that you definitely want to understand to give you great success before sitting for the AZ-104. Great to understand that a container group is useful for building a sidecar for logging or monitoring, or maybe you have one group that is responsible for the web app and the other one is responsible for monitoring. So a group gives you a fair amount of access for quick startups, but definitely want to compare and contrast ACI with other options such as Kubernetes for the exam. You can also deploy a multi-container group option with a YAML file. YAML file is a way to configure a container group. You're going to provide with a YAML file, provides us a convenient way to configure a container group for repeatability, repeatable deployments, and we're able to be very concise in nature as to what we'd like to have deployed um, when our deployment includes only container instances. So we can be descriptive. A YAML file, remember from our study, gives us a place to define the configurations associated with the container group. Gives us consistency, repeatability. So those are features that you may see as an option on your exam. Very similar to ARM templates, but definitely there are some differences, so don't conflate the two, in other words. You mentioned Docker. We kind of flashed past Docker a second ago, but Docker is not necessarily a competing platform. It is a complementary one. Docker is a platform that loads and creates containers for you using special recipes for Docker images. So there are some components that at least you should be aware of. You don't have to memorize and know everything Docker based, but consider Docker when you're using or need to have an orchestration platform. So it enables application hosting within a container, is available on both Linux and Windows, and can be hosted in Azure. Remember what a hub is, or a registry. That would also be synonymous with ACI, container registries. And a hub is essentially a repository where things are kept. So anytime you see Git Hub, for example, or Docker Hub, usually that will be associated with repository. The engine, the server, the REST API, and the client are all components you should know by now. If you don't, brush up on those, as well as the Docker file, which is essentially going to allow you to create a wish list of the things you'd like to create. So, Docker file, similar to our conversation about YAML files, describes the order, the precedence, what we'd like installed on that in that container. Kubernetes, Azure Kubernetes Service, or AKS, is a wonderful way to manage orchestration. So there are some differences between these products, which require you to do a little reading, but AKS essentially allows you to scale, allows you to orchestrate your deployments. ACI uh, doesn't have an orchestration feature, so That's a wonderful, great way to deploy things quickly. But if you want to scale, if you want to manage the number of nodes and pods per deployment, then AKS is where you want to be, right? AKS versus Docker. AKS runs across a cluster. Docker runs in a single node. There are some differences there that you may want to read up on. Speaking of scaling, AKS allows you to horizontally scale your pods using some metrics-based rules, for example. That would be one way to scale. When your application grows beyond a capacity for a single pod, this autoscaler with AKS will adjust that capacity in the following ways using the horizontal pod autoscaler, which scales based on metrics, or the cluster autoscaler, which scales based on compute resources. So you have options there. Important that you understand the differences, the different parts, components rather, of an ACI deployment versus an AKS deployment. There is still a concept of nodes, but with AKS, we have pods as well. Pods are where your containers reside. So some of the terminology might be slightly different than ACI, and that's something you want to keep track of. But Kubernetes simplifies the deployment of managed Kubernetes clusters in Azure by offloading the operational overhead to Azure. There's a hosted, customer hosted portion, a Microsoft Azure managed portion. Which is which? Do you know the difference? Probably a great idea to take a look. AKS is free. You only pay for the agent nodes within your cluster, not the masters. So understand those components as well. And then the networking components that you're able to configure with AKS versus ACI. AKS allows you to use a cluster IP to provide access for internal traffic to your pod, for direct traffic to the node, incoming direct traffic that you have a map port to represent your node port. Understand that difference. And you do have, these are all separate options, right? You have the option to configure a load balancer to start distributing traffic to various AKS node ports to various pods. So a couple options that you should keep track of, and you'll be gearing to go for the exam. Azure App Services gives us a way to deploy HTTP-based service for hosting web apps, REST APIs, mobile backends, for example. We can run applications that can scale easily on Windows, on Linux. A great idea to understand that app services, we know from our study, app services run in app service plans, and plans allow us to deploy within it various web apps or applications. Right? And we have various types of plans which support our underlying compute or resources. True or false, we can have multiple apps within an app service plan. Absolutely. We can, that was no pun intended. Absolutely, we can. An app service plan or app services allows us to take advantage of features to include continuous integration with repositories like DevOps, GitHub, Bitbucket, FTP, local Git repositories. Allows us to use integration with our favorite editors like Visual Studio, and does have automatic scaling based on your workload that you can deploy as an option based on your plan or feature set. So don't forget to remember that most of your resources in Azure do have tiers or licenses or SKUs or AKA features. And app service plans allow you to choose to configure the plan that works best for you. You will create an app service plan in a specific region. You can have multiple app service plans, but they are pinned to a region where you will create your resources and run your app services within them. Some considerations for governance might be, again, the region, the number of VM instances. and the size that you're going to elect within the pricing tier, like we see in this app service plan example on the right. You can also identify plans um, or choose to identify app service plans in your app service environment by noting the location under the plan name, simply meaning that that your pricing tier and all of the project details that you include will start structuring where your environment will live, right? And as a case study, you may see an environmental example in your uh, AZ-104 exam that hypothetically mentions an existing environment that has an app service uh, plan with multiple applications in it. And maybe it asks you the correct solution. Is this one correct? Is the next option correct? Maybe the third option says that I'm able to move application service plans without any downtime to my applications. Which one is true or false? We know that to be true. So it may give you multiple examples of how to execute one solution, and you'll have to pick the best option before moving on to uh, another question. So a case study or a simulation could go that way. App service plans, certain app service plans do allow scaling, and this brings us back to memorization of what's available per plan. Every app service plan does not offer scaling. There are a few types outlined in the example here that we see. So we have a free or shared tier where we can run an application on the same virtual machine, and the cost will have to do with how much compute we're consuming, basically, consumption-based cost. We have options for basic, standard, premium, V2, premium, V3 that run on dedicated virtual machines as well. Um, well, as an option if you need it, as well as being charged for the virtual machine instance that you're using. And we also see that there is a plan where our virtual machines can be dedicated within a specific virtual network, and we're charged for that isolated work in that plan. So know the differences. Know that some of these tiers offer deployment slots. What is a deployment slot? It allows us to customize our connection settings, our application settings. It allows us to switch between our code deployments in app services. It allows us to, for example, create deployment slots for staging, for tests, for various scenario-based options. And you have the ability to map your settings based on how you'd like to move that code. So definitely a great idea to put that into your pocket. Creating app service plans looks a little like this. We have a few portions or steps within the full life cycle of an app service if we're going to create an app service plan. Step one, create the app service. Think about how you're going to secure the app service. Customize any domain names that maybe if you want to bring in a custom domain name, validate it, understand how you have to map that DNS registry or set up that registry or zone mapping for that app service plan. Don't forget to think about backup. Of course, you're going to configure your network settings to coordinate your communication within your virtual network, as well as those deployment settings that I mentioned a second ago. Really key here to think about the options that are sticky, that are going to stick to a swap or cloning or change to the code that's deployed from one slot to another. Which settings are going to follow that change if you decide to clone code, for example, from one deployment slot to another? You may be asked also, hey, in what order would you perform the following tasks? Say you work for Contoso and you are charged with adding a custom domain name to your app service plan. You have steps 1, 2, 3, and 4. But they're all swapped, they're all mixed up, and you have to resequence these in the correct order. Are you able to do that before your exam? Well, let's get into some practice questions for our preparedness. Question number 1, you're running an application consisting of microservices that require persistent storage. Which of the following solutions provide the most optimal performance? Number 1, VM with a VHD, virtual hard disk. Number 2, VM with Azure Files. Number 3, containers with Azure Disks. Or number 4, containers with Azure Files. You're running an application consisting of microservices. The correct answer is number 4, containers with Azure Files. So we're able to mount file shares that our containers will use, and think about things like persistent claims. Think about the life cycle of um, that particular storage option. So those are also key details that you should know for the exam. Number 2, which of the following resources are deployed in this template? Let's see, we have a JSON template with a schema, which is required, with resources, which are required. And okay, number 1, storage account. Number 2, NSG, network security group. Number 3, load balancer. And number 4, public IP. Let's look at our resource types. The correct answer is storage account and network security group. So if we look in as our resources are listed here, we see references to our storage account as well as our network security group, but none of these other options as um, types that we would manipulate in this JSON template. Let's review what we've covered in functional area 3. Here are the key topics that we've discussed that will prepare you for this functional group. We discussed ARM, Azure Resource Manager, JSON files and templates. We discussed Azure Compute Gallery and how to create a virtual machine and use and rely on that gallery to help us do so. We talked about creating resource groups, objects within resource groups that allow us to move virtual machines from one group to another. We also discussed managing resource sizes for VMs for compute workloads and connectivity, mapping data disks, managing skill sets and availability sets for high availability and triggered deployments. We talked about containers, microservices, using ACI, Azure Container Instances, managing our Docker or YAML files, and thinking about AKS to scale, to orchestrate our deployments, as well as using app service and plans to create an easy way to create multiple options for compute underlying our app services. Thank you for joining me for Skills Measured Area 3, Deploying and Implementing Compute Resources. I hope to see you back for Skills Measured Area number 4, Configuring and Managing Virtual Networking.